The Denary number system, also known as the decimal number system, is a base 10 number system that makes use of the numbers 0 through 9 to numerically represent whatever you want. So some examples would include 1, 2, something like 532. Computers use the binary system, which is a base 2 number system, and your options are either 0 or 1. So this is your off and on state. So each digit is also known as a bit. If we have 8 bits, that's a byte. So let's say we wanted to represent a denary number. Let's say we wanted to convert 155 to binary. What would we do? So to start off, we would make a header. We start off with 2 to the 0th power, then 2 to the 1st power, and so on. Till we reach 2 to the 7th. So if you're not very good with exponents, you could also write 1, 2, and then continue doubling. Till you reach 128. So since we have 155, we would start with the most significant bit, which in this case would be 128. So we have to check to see if 128 is less than 155. In our case it is. So we put a 1, and then we subtract 128 from 155, which would be 27. So we move on to the next bit, and we see is it less than 27. 64 is not less than 27, so we would make that a 0. 32 is greater than 27, so we make that a 0. 16 is less than 27, so we subtract from 27. We get 9. And we make that a 1. Now for the last bits, we would just do 8 plus 1. And set everything else to 0. So minus 8, minus 1, 0. So our binary evaluation would be 155 base 10 is equal to 1 0 0 1 1 0 0 1 base 2. We could also start from binary and convert to decimal. So let's say we started off with 0 0 1 1 0 1 1 0. So we will start off by making a header. So 1, 2, 4, 8, 16, 32, 64, and 128. And we simply add up everywhere where we see a 1. So 32, 16, 4, 2. We'll get 54. Which means that 0, 0, 1, 1, 0, 1, 1, 0 base 2 is equal to 54 base 10.